sklearnensembleAdaBoostRegressor. Description: AdaBoostRegressor is a powerful ensemble learning algorithm for regression tasks. It combines multiple weak learners, typically decision trees, to create a strong learner that can achieve high accuracy. The algorithm works by assigning weights to each training instance. Instances that are misclassified by previous weak learners get higher weights, thus forcing subsequent learners to focus on them. This process iteratively improves the model's performance by focusing on difficult to classify instances. Inputs: XA2D array containing the features of the training data. Each row represents a data point, and each column represents a feature. YA1D array containing the target values for the training data. The target values must be numeric. Outputs: fitted model, the trained AdaBoostRegressor model. This model can be used to predict target values for new data points. Predictions: when the fitted model is applied to new data, it generates predictions for the target values. Steps: initialization: initialize the weights of all training instances equally. Iterative learning: for each iteration, fit a weak learner, typically a decision tree, to the training data. Calculate the error of the weak learner and update the weights of the training instances based on the error. Model aggregation: combine the predictions of all the weak learners using a weighted average, where the weights are determined by the performance of each weak learner. Metrics: mean absolute error may measures the average absolute difference between the predicted and actual values. Root mean squared error RMSE measures the square root of the average squared difference between the predicted and actual values. R squared measures the proportion of variance in the target variable that is explained by the model. Visualization plots: feature importance plot shows the relative importance of each feature in the model. Residual plot plots the difference between the predicted and actual values. This can help identify patterns in the errors and reveal potential issues with the model. Fine-tune parameters: estimates the number of weak learners to use in the ensemble. Increasing this value generally improves accuracy but can also increase training time. Learning rate controls the contribution of each weak learner to the final prediction. Lower values reduce the influence of individual learners, making the model more robust to outliers. Uncertainty methods: bagging: training multiple AdaBoostRegressor models on different subsets of the training data. The predictions from these models can be averaged to estimate the uncertainty in the predictions. Bootstrap aggregating: bagging, a technique for reducing variance in predictions by creating multiple models on different subsamples of the data. This can be used to estimate the uncertainty of the model's predictions. Challenges and fixes. Challenge 1: overfitting. If the number of weak learners is too high or the learning rate is too large, the model can overfit the training data and perform poorly on new data. Sample use case: a model trained with 1000 estimators and a learning rate of 1.0 overfits the training data and generalizes poorly. Fixes: reduce the number of estimators, decrease the learning rate, use early stopping to prevent overfitting during training. Challenge 2: high variance. If the data is highly noisy or there are outliers, the model can have high variance, leading to unstable predictions. Sample use case: a model trained on noisy data exhibits large variations in predictions for similar data points. Fixes: use a smaller learning rate. Regularize the weak learners, e.g., by using L1 or L2 regularization. Consider using a more robust base learner, e.g., a decision tree with a larger minimum leaf size.